always want to use the whiteboard. I think I would like to, before I start, just review this very important concept. Okay? So, you don't have to write this down, you just have to pay attention, right? If there's a low range between the values, right? And remember, range is the difference between the lowest and the greatest value in the set. You will also have a low, what we call standard deviation. And right now, the standard deviation is just like a number we sort of calculate, we type it in, and it just, here it is, right? But it is like, it is a measurement, right? It tells you something about data. But on its own, it doesn't mean much. On its own, it doesn't mean much at all. But when you take that standard deviation and compare it to another set of points, you're like, oh, look, the standard deviation went down. So that means that my data points are probably clustered a bit more. They're closer together. So those are the kinds of things that we use the standard deviation for. Okay, so a low range will result in a low standard deviation, which means consistent data. It tells you that if you were to plot these points, right, like if you made a line, it doesn't matter where on this line, at some point you would have data kind of cluster around an area, right? So if you were to draw a curve over it, oh, look at that bell curve, right? But it would be clustered. The data points as you're collecting them, they're just like huddled, right? If you have a high range, that means that you will, and you should have seen that relationship, a high standard deviation, right? Inconsistent data. Okay. And so when you collect your points, they're going to be a bit more scattered all over the place. You may even have some significant outliers. So if you graph this curve, it would be a lot flatter and more stretched out. So this is perhaps one of the most important points that I was trying to make yesterday. So a lot of times you want a low standard deviation. For example, Amazon, right? A lot of us buy stuff from Amazon. I buy stuff all the time. Yeah, I buy stuff all the time. Like I barely go to the stores anymore. And even if I'm at a store, I'm looking at that as like, I'm going to check out if it's cheaper on Amazon, right? I'm pretty sure a lot of you do the same. But what I look at when there are reviews, you know what I don't like to see? 1 star, 5 stars, 1 star, 5 stars, right? You notice that? That it's inconsistent. It's not consistent, right? It's like all over the place. Like the company makes some good stuff, and then some of them are made on a Friday evening, right? You know that expression, right? It's made on a Friday at 5. They didn't really do a good quality check on it, whatever. But it's just all over the place. But if I see an item that maybe only has 4 stars, right? So not the highest, but if it's 4 stars and the reviews are like between 3 and 4, maybe 5, it's a bit more consistent. Then I'm like, you know what? I think this is a pretty good product, right? So consistency is what you want. You want the stars, right, to be closer together, so you know, right? It's a soccer player or a goaltender or whatever, a volleyball player, whatever, right? The more consistent you are, the easier it is to work with it, right? And it'll be a steeper curve. Like if you once you put them on the number line and you try to like draw a line, kind of trying to encompass your data, right? It would be steeper as opposed to, right, flat curve. Okay, so when it came to COVID, they wanted a higher standard deviation. They wanted it to be like, let's scatter it. We don't want all patients coming in at the same time. We want that to be flattened. We want to flatten the curve. That's exactly what it was, all statistics, really. flattening the curve was really talking about this, right? That we're talking about. And so I think right now I want you to just really pay attention to the standard deviation and how does it translate to the data that we're perhaps making a visual representation of. Okay, so I hope this helps a little bit more, just giving you a bird's eye view, right? So that when you're zooming into a question, ultimately you're always thinking of this in the back of your heads, right? You're always making this these connections, right? And we're going to talk a lot more about this, but for now we're just going to put it on hold. We're going to go back to page 6. The two batteries, right? The brand X and brand Y, right? Duracell and what's the other one? Energizer, maybe, right? So when I hope you typed this in, and if you did your homework, it's still everything is in L1 and L2, right? So look, I typed it all in this morning, and then I was working on quadratic stuff, and I cleared all of it, and I had to redo it. So, anyways, I typed in brand X into L1, brand Y into L2. If you can, do it quickly, but I'm going to move on. Okay, so it asked me or us, right, to calculate the MCTs, that's the mean, median, and mode, standard deviation, as well as the range for each of the brands. And notice that I put the keystrokes in just to let you know, right, what am I doing here? So I went stat, calc, I call one variable statistics, and I feed it all the values that are in L1. And right away, the average lifespan is 5.74 years. The median, which is found by going arrow down, right? It's right there, 5.75. The standard deviation is right here. Watch out, some students mix these up. How about you go find n and then just go up? That's standard deviation right there. It's 1.22. Oh, minus half right there. It's in years. Whatever you're in, that's what it's. Those are the units we associate. The range, right? If you go through to the bottom here, right? Take the max, which is 8.2, subtract the min, right? The highest and the smallest value is 5.1 years difference. And then the mode, that one, how do you find that one again? It's not going to give it to you. You have to find it. Sort, yes, you have to sort your list. I put that down. Sort in ascending order, right? And you got to feed it. So you got to go stat, sort is right there. I'm going to sort L1, hit enter, and then watch what I'm going to do to make it faster. Second enter, right? I call that. I go back arrow, second 2. So I will sort both columns because I know I'm going to have to go back anyways. And so stat, edit, and you just scan it. I put 5.7 years. And so if you go through it, you see 5.7 appear 3 times, right? So that is your mode. Watch, I'm putting down n is equal to 30. I encourage you to do that, check, right? Like if you go back to your data set when you have lots of points, right? 5 times 6, you should have 30 values in your L1. So I just put that down to make sure I get that right. I don't miss one. I did the same thing for brand Y. So I'm going to go stat, calc, one variable stats, and I'm going to feed it L2 this time. And there I got 5.72. My median was also 5.75 right there. So what is that telling us? That half of the batteries last less than that, half of the batteries last more than 5.75. Okay, that's what the median is telling us. Watch this, standard deviation is about half of the previous. So now it makes more sense to us. Like, I don't know what that really means, but if I compare it to another brand, this one is more consistent, right? because it has a smaller standard deviation, so there it's good. And there you should also have noticed that the range, if you subtract the max and the min, you would have totally expected your range to be smaller. At least I hope so. And the mode was 5.9 years, which showed up 3 times as well. Just happens to be the case, okay? So this chart should have been fairly easy for you to fill in. If not, right, you had the video to go back and do that, okay? And now we'll do the line plot. I actually decided to leave that blank because I wanted you to, if you did it already, great. That's what I wanted you to do. But we're going to go ahead and do that here. So if you have a ruler, I always like to start with my line here. Okay, so I'm going to make a line plot for brand X. There we go. Yeah, so that should be fine. What's that? Oh, you don't have the booklet? So brand X is going to go here. And let's just figure out the scale, because this is the trickiest part of all, perhaps. Go to your, I guess we already did that, right? I need to go, I'm just going to write it down here. My lowest value is 3.1, my highest is 8.2. So 3.1 to 8.2. I'm just going to write that down here. That is what I need to make sure I accommodate. I have to have room for those points. And so if I start, let's make our second line here. Just leave a little bit of space, and I'm going to try to make them about the same. I would like them to be about the same so I can compare them side by side, right? And my range there is, I'm just going to peek here, 7 to 4.5, right? So I don't really need this to be on the graph, but I have both of those there. So you can go from 1 to 9 or 2 to 9 or 3 to 9, something like that. Let me see here. I will try something. If I make this 1, and I'm using my ruler just to help me out, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's good enough, right? I'm just going to leave it at that, and then you just put arrowheads here, and I'm just going to call it, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You may have used a different scale. If you did this for homework, totally fine, okay? If you started at 3 and went 3, 4, 5, 6, 7, that's fine. And this is in years. You got to make sure you have your units labeled. We can also say that this is brand X, right? Lifespan of brand X. I will do the same thing below here. Watch. I'm going to start right there. So ideally, if you're comparing, you want to have the same scale. Ideally. But it's not necessarily wrong if you don't. So this is in years, and this is brand Y. Okay. And I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good enough. So I know when I look at the range, I know for sure that I'm going to fit all my data points on this here, right? Because I have actually, I'm going below and above the min and the max. So both are taken care of. Now you want to grab your calculator and go to your sorted list. And I'm going to start with L1, and then you plot them. And you kind of want to scan ahead, right? So 3.1 would be right there. 3.3 would be right there. 4.1, 4.3. Oh, no, 4.3 is here. 4.6, 4.7, 4.8, 5. It's a little bit cramped there. That's okay. 5, another 5, a 5.1, a 5.2, 5.5, 0.7, 0.7, 0.7. That I should be able to see clearly that there are 3 5.7s there. 5.8, 5.9. Oh, it's a little bit crowded. Can I start again, guys? Sorry. No. Why would you do that? I will do dots. Okay. I will do dots. I'll start again. I want it to look good for your notes there. So 3.1, 3.3, 4.1, 4.3, 4.6, 7, 8, and then there's the 2 5s. So I'm going to stack those. 5.1, 0.2, 0.5, 0.7, 0.7, 0.7, 5.8, 5.9, 6, 6.1, 6.2, 0.3, 0.4, 0.4, 0.6, 0.8. It's pretty crowded, but 7.3, 7.5, 8.1, 8.2, and that's it. So that's my line plot. And again, I won't dissect it. I won't like, oh, wait a minute, that one should have been like 1 millimeter over. As long as it's in the area where it's supposed to go, I'm fine. And I should see the mode and everything. Let's do the second one here. As you can see, it's a bit like this is where practice comes in to know what should I do to speed things up, right? So 4.5, 0.7, 0.8, 0.9, 0.9, 5, 5.1, 0.3, 0.4, 0.4, 0.5, 5.6, 0.6, 0.7, 0.7, 0.8, 0.8. Oh, this is again not working out for me. Hold on. It's frustrating, I know. So you just gotta stick through with it. Let me try again. Here, 4.5, 0.7. I'm gonna go closer together. 0.8, 0.9, 9, 5, 5.1, 5.3, 0.4, 0.4, 0.5, 0.6, 0.6, 0.7, 0.7, 0.8, 0.8, 0.9, 0.9, 0.9, 6, another 6, 6.1, 6.2, 0.3, 0.5, 6.6, 0.8, 0.8, 7, and that's it. So it's pretty crowded there. And ultimately, you should still see the difference. You should still see that this is spread out. This is more compact, right? And I will just make them, right, that's my mode, which is 5.9 years. My average is 5.72, so it's right about there. And my median is 5.75. So we'll just go arrow from the top here, median 5.75 years. So everything is pretty close together actually here, okay? And the top here, my mode is right there, 5.7 years. My mean is 5.74, somewhere in there, 5.74 years. And the median is 5.75. So somewhere in there is your median of 5.75 years. Everything is pretty close together as well in terms of the mean, median, and mode. But that would be a complete line plot for both of them. Okay, I will just make a note here. Smaller SD, 0.64 years. Was it 0.64 or 62? 64, yeah, we're good. And this one was larger standard deviation, 1.22 years. That's just a side note, okay? I just like to, you don't have to have that on your number line, but it's good to see, okay, I can actually visually see that this is clustered, compact, more consistent. This one is a bit more spread out. Okay, so which company would you want to buy a battery from? If price was not an issue. If price is not an issue, then you should say this one, right? Because you're not going to have a battery, right, that lasts only 3 years, right? And right, in this case, you don't go as low as 3, you go as low as 4.5, right? So it's better. Consistency is better most of the time. Describe each data set using the mean, the range, and the standard deviation. So here we go. Okay. Brand X. Slightly higher, greater, mean, right? So it technically, they could say, hey, ours lasts a little bit longer on average, right? Greater range. Means, right? Inconsistency. Life spans. Greater standard deviation. Data is spread out. Is more, I should say more spread out. Sorry, is more spread out. Brand Y, okay, lower average, and I'm doing that on purpose. Lifespan, smaller range, which means more consistent lifespans, more consistent lifespans. And if you want to talk about, right, smaller SD, You can also use the symbol, right? Data is clustered. You could talk about the curve if you wanted to. Just make sure you let me know that you know how everything is connected. You could have also said a smaller range will result in a smaller standard deviation, which means that data is clustered or consistent. Like these are technically all connected. Okay. Which brand would you recommend? I would recommend brand Y, since it is more reliable / consistent. Lower standard deviation, right? If you want to talk about like why do you know that you would pick it without even a graph, I would just say, hey, the standard deviation is lower, it's more consistent. What are other factors that should be considered before making a purchase? Price, of course, warranty, customer service. You see that on Amazon sometimes, right? Terrible customer service. That's why they get 1 star, right? Nobody picks up, nobody answers, right? So I would consider that if brand X, if brand X is like half or less of the price of brand Y, I take risks, so I would just go for it, right? Like if it's cheap enough, I would still go for it, right? And depends on what I'm going to use it for and how important it is, right? For my day-to-day function. Anyway, so if you want more practice, there's the textbook, but we're kind of moving on after this. So I'm going to give you an AC here. So just make sure this book is closed. So the yellow, I can see yellow, but it's right, not the rest.